One of the things I try to focus on in this class, in addition to talking about reactive programming and talking about WebFlux and WebMVC, are ways of structuring code. And one of the things that we've talked about a number of times that are very helpful is this concept of not repeating yourself. And so we're going to talk about that here to talk in the discussion about common structure and functionality that extracts out code that would otherwise be repeated in multiple places and put it in a common place. So this is the common module, and it includes this thing called the base application, which we'll talk about, which factors out common code from the handy and zippy applications, as well as the quote class, which is essentially something that can be used to pass data back and forth between client and server, as well as also be able to handle information that's stored persistently. And there's this ArrayUtils class we'll talk about briefly as well, which is really more useful for the handy microservice. So let's first talk about base application. This defines a Eureka-enabled microservice foundation. And the idea here is that the different microservices we implement, like handy application and zippy application, will both extend the base application. And what the base application will do is it will have its own run method, which under the hood uses the Spring run method, and it's going to take the class that's passed to it, which will either be the handy application class or the zippy application class, and it extracts from that the name of the application. And it uses that name to register with the underlying Eureka system with a canonicalized name. So this name will then be what's used when this application is going to register with the system. Let's talk a bit about the quote class. So the quote class is very important. The quote class serves two purposes here. One is to be able to be the means by which we send quotes from either zippy or handy back and forth between the client and server, number one. And number two, it's also used as an entity to be stored in a persistent manner by either JPA or R2DBC. And this required a little bit of fancy footwork to get this to work, and I'll talk about that here. So the first thing you notice here is this class is tagged as being an entity, which means that that annotation instructs the various persistence mechanisms we're going to talk about, that it should be stored as a persistent object in a database. And the database table is going to be the quote table here. As you can see, we then have a couple of fields. The first field we're going to look at is the ID field, which is an integer, and this gives the ID of the quote. Everybody starts out with a unique ID, every quote, and this serves as the so-called primary key. And in order to get it to work as a primary key, we have to provide annotations. And this annotation, which uses the @ID annotation, that instructs the Java persistence architecture to treat this as the primary key. And this other annotation, the org.springframework.data.annotation.id, that's the one that's used for R2DBC. So this is the way we specify this. And it's a little bit tricky. It took a little thinking to figure out how to do this because we're actually using two different annotations for two different purposes, and the magic of the JPA and R2DBC ferret out which thing has to be used. Sadly, you can't use one annotation for both of those persistence mechanisms. Then down here, we actually have the quote field, which will be a quote, like a zippy quote, such as, "Yow, am I cleansed yet?" or a handy quote like, "It takes a big man to cry, but it takes a bigger man to laugh at that man." Those are the quotes that will be stored in the respective databases, and these are just stored as strings. Then, and this should look very familiar at this point, we are going to make sure that we can use the quote in the context where things have to be sorted. So for things to be sorted properly, we can implement the comparable interface and parameterize it with a quote type that we just defined over here. And then we have the compare_to method, which uses this clever null-safe comparator, where we're going to allow nulls, but we're going to make them come first. They're the lowest value if you have nulls. And that way we can compare them to ignore case while being null-safe. And likewise, we also have an equals implementation that is also null-safe, and it compares two quote objects to see if they're equal. And this is also kind of cool because it's using this newer feature that came into Java, which is this pattern matching instance of operator. And as you can see here, you take the parameter that's passed in here, such as the O parameter, and you basically downcast it to see if it's a quote. If it is indeed a quote, then we have an object called Q of type quote, and then we can use that here to see if these values are equal. If it's not a quote, then it'll fail right away. So nice, clever way of doing things. I strongly encourage you to sort of memorize that way of doing stuff because it's very helpful in practice to be null safe. The last piece of the puzzle, which I will just touch on briefly here, and then we'll look at it when we go through the code in more detail, is this ArrayUtils class. And this also took some head scratching to figure out when I wrote this code last year. So I bundled this up into a reusable artifact that others can benefit from, because there's a few little quirks when you deal with R2DBC with respect to custom queries. And what happens here is this will be used, this ArrayUtils has a set of static methods that are used to convert various objects, which is what are going to come out of R2DBC, into the concrete types that we care about. So there's a method called obj2list, and it takes an object that's passed as a parameter and a class of type T, which is generic, and it attempts to convert the object here into a list of elements of type T. And you can see if it works, you get a list of type T back. Very, very useful for purposes, as we'll see shortly. Likewise, also very useful is this other helper method that converts an object to a number subclass of type T. And this turns out to be very helpful for things like making integers or longs or whatnot. And you'll see when we get into the code how it works and what relevance it provides. But it's very useful stuff. I worked closely with ChatGPT from a year ago to figure out how to do this. It took a couple of iterations, but it worked fine, and it's a really nice reusable artifact. So that's the end of the discussion of the common structure and functionality. We're next to go take a look at the code and see what it does.